Good day, Miss Yesa. We are Group 3, and today we are going to present to you four different functions that are used in geoscience. The first one we are going to discuss about is the oceanographic distance, which is a type of trigonometric function. Now, this function has 6 types. Although we only flash the most common ones here, the sine, cosine, and tangent. For the function of the sine, its opposite is equal to opposite side of the theta. Hypotenuse, the longest side of the triangle. Adjacent is the adjacent side of the theta. Now, why is an oceanographic distance is a trigonometric function? Well, first of all, our independent variable is on the tangent here. We're also looking for that. Why? The variables, our formula is this. Y is equal to the opposite over tangent x. The independent is the adjacent, which is y. The dependent is the angle, which is tangent x. And the constant is the opposite, which is like this. Constant, dependent, and independent. The domain and range is for both are for the domain is x is greater than 0, while the range is y is greater than 0. The inverse of the function is that tangent y is equal to opposite over x, wherein the independent is the adjacent, the dependent is the angle, and the constant is the opposite side. Now, if you graph the given function earlier, it would look like this. The asymptotes and zeros are as follows. We have a pattern where you just increase the numerator by a whole number, which is 1, or decrease it, and then as the denominator, just divide it by pi. And the asymptotes are, there's no asymptote for the horizontal, but there are two vertical asymptotes, which is pi over 2 and 3 pi over 2. And if you replace the equality sign with a greater than sign, which is the one we used to replace it and use an equality, the graph will look like this. Now, what happens when you add the function to another function? When you add function y is equal to 20 over tangent x, when you add it to a function y is equal to 30 over tangent x, it will produce a larger distance, because this is a distance, this is a distance, distance plus distance is more distance. Thank you.
Richter scale. This is an example of a logarithmic function. Richter scale is an example of a logarithmic function because the whole number jumps indicate a 10-fold increase, because each number on the Richter scale represents an intensity 10 times stronger. The formula is m equals log I over s, wherein m represents the magnitude, I for intensity, and S for the standard intensity of an earthquake. The dependent variable is the magnitude, M, and the independent variable is the log I. The domain is x such that x greater than 1, and the range is y such that y greater than 0. The inverse of the logarithmic function is 10 raised to m equals log I over s. The inverse was determined by getting the exponential form of the function, since the inverse of a logarithmic function is an exponential function. Here is the graph of the logarithmic function. Logarithmic functions has asymptotes x equals 0, given that no conditions are given. Here is the graph for when the equality is replaced by an inequality. The functions that can be combined with log is an exponential function, which you can just transform into a logarithmic function. Multiplication is the operation used to combine the two functions. According to the laws of logarithm, when adding two logs together with the same base, the arguments of the two logs are multiplied. So an example is log 10,000 plus log 1,000 is when you multiply that together, it is log 10 million. So, in conclusion, the magnitude will increase if combined. Thank you.
Latent heat. So, the latent heat function is Q equals ml, where Q is the heat required in joules to change the state of object. M is the mass of the object in kilograms, and L is the latent heat of object in joules per kilogram. So it is a linear function because it has a straight line, it has a degree of 1, its form is y equals fx equals bx plus a, and it is a conditional function because its mass is restricted. Its independent variable is mass, which is m, and the slope and coefficient is the latent heat. The dependent variable of this function is heat, which is Q. So its domain is mass is greater than 0, and the range is less than 0 if the latent heat is negative, and it is greater than 0 when latent heat is positive. So its inverse function is m equals Q over L. So to derive this, we solve for m. So the mass will be the dependent variable and the latent heat will be the independent variable. Next, this is the graph of Q equals 14,000 m. And this is the zeros of 14.
47.
Wala.
3, 2.
Parang sasabihin yun.
The zeros and asymptotes of
The zeros of the function.
Of the function na lang. Sige.
Go.
The zeros of the function is none because since mass can be 0 and latent heat can be 0, and its asymptotes is also none. So this is the graph when Q is greater than 14,000 m. So this implies that the heat absorbed is greater than the required heat to change the state of object, which is 14,000 m. So this results to faster time to change the state of the object.
Go.
So for the combination, we use addition and subtraction. In this case, we use conservation of heat, which is Q lost plus Q gained equals 0. And as you can see, when we add all the joules, the answer would be 0.
So today I'm going to explain about the exponential function which our group used the half-life. So the formula of the half-life is A equals AO times 1/2 raised to T over H. So when we move on to the quantities, so A here means the final amount of the decay substance, and AO is the initial amount of decay substance, T which is time, and H goes under half-life. So for the quantities, we have A for the final amount of decay substance, which is the dependent variable, and ATH, which are initial amount, time, and half-life, which are all independent variables. And this is the graph of the function if we apply a context of 10 grams for the final amount of decay, and 100 as the initial amount of decay, and 20 as the half-life, and this is the formula of getting the time needed for the decay. So next, based on this graph, if we get the domain, range, and asymptotes, the domain is all real numbers, range y such as the y is greater than 0, and the asymptote goes like this, y equals 0. For the inverse function, which we could make diverse functions, we can derive diverse functions from the original function. Here, our group made this inverse function in order for us to get the time. And as we got the inverse function, t is equals to 20 log based 1/2 of AO, and it is multiplied by A. Thank you.